In this video, we're going to be adding geometric vectors, but it's going to be a little bit more complicated this time. If you have two vectors acting in the same direction, the overall magnitude is equal to the sum of the two individual magnitudes. If you have two vectors acting in opposite directions, the overall magnitude is equal to the difference of the two individual magnitudes. But what do you do when you have not this clear-cut example of adding two vectors? Well, not all forces act in the same or opposite direction. Therefore, we're going to need some trigonometry to determine the magnitude of resultant vectors. Okay, so we're going to use a few things here. We're going to use Pythagorean theorem, trig ratios, sine law, and cosine law to help us with these calculations. Just remember that if sine theta is positive, then theta could be in quad 1 or quad 2. So you're going to find both angles and then determine the correct angle from your diagram, which should be accurate. So you do your best as best as you can to draw an accurate diagram given the circumstances, right? So like, you want to make sure that like a 60 degrees looks approximately like 60 degrees, 45 looks like 45-degree angle, and then make sure that your magnitudes are pretty reasonable. Okay, so vectors A and B have magnitudes 7 and 12 respectively. The angle between vectors is 40 degrees. Describe the magnitude and direction with respect to A and B of C, which is the resultant of 3A plus B. Okay, so we're going to do a few things here, okay? I just want to identify right here that if we say the angle between the vectors is 40 degrees, just remember that if it's the angle between the vectors, I'll do it in red here, angle between the vectors, that means tail to tail, is 40 degrees, okay? And when we add vectors, which we're doing right here, we have to add them tip to tail. So let's just put in that little note there, right there, tip to tail. Okay, so let's start. I'm going to do 3a, and if I take 3 and I multiply it by 7, that gives me 21. So my baseline vector here of a is going to have a magnitude of, say, 21. Okay, I'll put that like up here. Okay, so this right here has a magnitude of 21, and that's because that is the magnitude of 3a. All right, and then what I'm going to do is I'm going to take the same vector here, and I'm going to copy it above it, and it has to be this one right here. This is going to be my vector b, and it has a magnitude of 12. So I'm going to change it so that it's like just maybe a little bit more than half, right? I think that's about right. And then I want to change it so that it's got about a 40-degree angle between them. Okay, so I'd say like this is like 45, so 40 is like maybe approximately this right here. Okay, and this is going to be my angle B, or sorry, my vector B, and my angle between them rather is 40 degrees. Well, we don't add vectors tail to tail, we add vectors tip to tail. So what I'm going to do is I'm just going to take this vector B and I'm going to move it over here. Okay, and I'm going to put this right here and then this right here, the magnitude of B, I can say is 12. Okay, I can now construct a resultant because I have them tip to tail. So let's put a resultant from this point right here to this point over here. It's going to be red. Okay, and this right here, I'm going to draw this, and this is going to be my vector C. And vector C is the resultant of 3a plus b, and I have to determine its magnitude and the angle it's making with A, okay, and the angle it's making with B. All right. Well, the first thing that I can do is I recognize that this B, 3A, and B here, because these two B's are parallel, these interior angles here, or these co-interior angles, are supplementary, which means that they add to 180 degrees. So this one right here is 140 degrees right there. Now, as you can see, I have a side angle side situation. So if I have side angle side, then I can use cosine law. And so cosine law will say that the magnitude of C squared is equal to 21 squared plus 12 squared minus 2, 21, 12 cos 140 degrees. If I evaluate this, then the magnitude of C is approximately equal to 31.2. Okay, so right here, my magnitude of C is equal to 31.2. So you can see that we're using these trigonometry laws that we previously learned in other courses and solving this triangle right here, which is giving us the magnitude of the vector. It's also going to give us some angles. All right, what I want to do now is I want to find this theta right here because that is the angle the resultant makes with A. So if I want to find that theta, then I'm going to write, okay, sine theta, I'm going to use my sine law, sine theta over 12 is equal to sine 140 over this side, which is 31.2. Now, if you want to get a really accurate value for theta, ideally what you should do here is you should preserve whatever this number is in your calculator with all its decimal places, and then you can sub that in into your calculation right here. And then you get theta is approximately equal to 14.3 degrees or 165.7 degrees. Because again, if sine theta produces a positive number, which it does in this case, then theta could be in the first quadrant or the second quadrant. So we have two options for theta. So you investigate and you look at the diagram right here. And if I look at the diagram right here, I can see it clearly is not an obtuse angle, so I'm going to discard this right here. So I know that this right here is equal to 14.3. Okay. Now what I need to do is I need to find the angle that the resultant makes with B. So that's this right here. That's my alpha angle. Well, I know that theta plus alpha must equal to 40 degrees because that's the total of this entire degree right here, this entire angle right here. So then theta is 14.3 degrees plus alpha is equal to 40. So by rearranging, I can find that theta is equal to 25.7 degrees. Okay, and so I'll come up with a final statement right here, and so I'll say, therefore, C has a magnitude of 31.2 and makes a 14.3 degree angle with A and a 25.7 degree angle with B. Okay. Let's move on to the next example. Okay, given U, it has a magnitude of 8, and it is north 25 degrees east, and V has a magnitude of 20, it's south 40 degrees east. Determine the magnitude and direction of W, which is U minus V. Okay, so this one right here, U minus V, another way of writing that is saying U plus negative V. Okay, and negative V just means like we're going in the opposite direction of V. Well, if we go in the opposite direction of V, negative V is going to have the same magnitude, but if it's going to be in the opposite direction, it's going to be north 40 degrees west. Okay, and you can see, I'll quickly show you this right here. You don't have to copy this out. But if I was going south 40 degrees east, okay, we'll say that that's 40 degrees, and I want to go in the opposite direction, well then that's going to be north 40 degrees west. Okay, so let's just get rid of that right there, now that we've explained what that negative vector means. So I'm going to take U, and I'm going to add that to negative V. So if I'm using compass coordinates right here, what it is helpful to do is it's helpful to create a grid, and then we can, or rather a set of axes, and then on that axis we can plot the vectors with their compass coordinates. Okay, so I'm going to start with vector U, and U is 8 north 25 degrees east. So what I'll do is I'll insert this vector right here, north 25 degrees east. So we'll say, oops, that's not what I wanted to do. Okay, let me insert this right here. There we go. Okay, so north 25 degrees east. So like that's my 45 right there roughly. So we'll say about, okay, yeah, maybe about this right here, okay? And we'll say that this is 8, okay? And then what I'm going to do is from there, I'm just going to move this. I'm going to set another set of compass coordinates at its tip right here. Okay, and for this right here, I'm just going to draw that this right here is 25 degrees. Okay, I'm going to set another set of coordinates, and I'm going to put my north 40 degrees west. So I'll insert this right here. I'll go north, and I'll go just shy of 45, so north 40 degrees west. And if that's 8, then this is really a lot longer. Okay, say like maybe this. Okay, we'll say that that's my 20. Okay, and this right here is 40. Okay, so I can use all of this information here to, now that I have 8, 20, I'm going to construct a triangle to give the resultant, which is going to be right here. I'm going to make this in red. Okay, and so over here what I'll do is I will find out what these angles are. So if this is 25 and this is 90 right here, then that means that this is 65. And if this is 40 and the whole thing is 90, then so this right here is 115. Okay, so I'm going to use all of this information here to find W. And so the magnitude of W squared is going to be 8 squared plus 20 squared minus 2, 8, 20 cos 115. So then the magnitude of W is approximately equal to 24.5. Okay, so this is 24.5. And so what I can do from there is, if I want to find this entire theta, so I'll put it in light blue right here. I'm going to find this theta, and so I'll find that theta using sine law. So sine theta over 20 is equal to sine 115 all over 24.5. And so theta is equal to 47.8. Sorry, theta is equal to 47.8 degrees, or 132.2 degrees. I can see right here this is an acute angle, so I'm going to discard this. Okay, and then I'm going to now find this small angle here so I can get my compass coordinates for my resultant vector. So if I know that alpha plus 25 gives me my theta, so then alpha plus 25 is equal to 47.8. Alpha is equal to 22.8. Okay, so if I know that this angle is 22.8, then I can say, therefore, W has magnitude 24.5, and then and direction north 22.8 degrees west. Okay, alternatively you could say 22.8 degrees west of north. Okay, moving over here, find the magnitude and direction of u minus v, given that u is equal to 5, the magnitude of u is equal to 5, the magnitude of v is equal to 8, and the angle between them is 30 degrees. Okay, so one way of looking at this right here is by making my u vector and my v vector. So my u vector right here is 5. My v vector is 8. And the angle between them is 30 degrees. Okay, and so it's going to be a bit longer. So it's going to be just slightly longer than that right there. So we'll say okay. And the angle between them is 30 degrees. Here's my 8. This is 30 degrees. Okay, Well, it says that I need to find u minus v, right? So if I want to find u minus v, that's the same thing as saying u plus negative v. So I'm going to take my v vector and I'm going to change the direction. So I'll take this exact same vector here. I'll take actually both. Okay. I'm going to take this vector, and instead what I'm going to do is I'm going to change its direction. Right there. Okay, great. So this is 5, this is 8, this is 30, and I can draw my resultant now. My resultant is going to go from the tail of this one to the tip of this one. I'll change that to red so we can identify it very clearly. Okay, so it finds the magnitude and direction of u minus v. So this right here is u minus v. I need to find its magnitude. Well, again, I'm going to use my cosine law. So u minus v all squared is equal to 5 squared plus 8 squared minus 2, 5, 8, and then we're going to say cos of 30 degrees. So the magnitude of u minus v is equal to 4.44 approximately. Okay. All right, and then if I say sine theta, okay, and what I mean by theta is this right here. Let's find this angle right there. Okay, so sine theta is equal to, rather sine theta over 8 is equal to sine 30 over 4.44. So theta could be either 64.3 degrees or 115.7 degrees. While looking at my diagram, I know it's not going to be an acute angle, so I can discard the acute. So it's going to be the obtuse angle right here. So this is 115. Oops, right there, that's 115.7, which means that this angle right here is 34.3. Okay. All right, so if this angle is 34.3, what I need to do now is I need to find the angle that this u minus v makes with the vectors u and v. So what I'll do is I'll take this vector right here, and I'll move this vector down here. Okay. So knowing that this vector over here, when I had it in this location, this was 34.3. That means that this entire angle right here, this entire angle is going to be 180 minus 34.3, which is 145.7. Okay, so the angle that u minus v makes with vector v is 145.7. So now what I need to do is I need to find the angle it makes with vector u. And the angle with vector u would just be 30 less than this, so 115.7. Okay, so we can just finish this off by saying, therefore, u minus v has a magnitude of 4.44 and makes a 115.7 degree angle with u and a 145.7 degree angle with v. Okay, great. So there's a whole bunch of questions right here that you can try, and the answers are provided. Okay, thanks for watching.